And I want to check. Can you see that? Yes.
Yes.
Yeah, we can say that.
Can you see my mouse?
Yes.
Yeah.
Yes.
Okay. Right. So mimic panels. What's it all about? So this isn't a presentation about this is the way you should do it. This is a presentation of the way that I've done it. I think obviously that some of the things I've done are really good. Otherwise I wouldn't be extolling their virtues. But there are lots of people out there doing all sorts of different things. So here's my first effort, just to give you a flavour of where we were coming from. So as you can see, this is a layout called Andover's Ford Junction, and it is my first sort of effort at railway. So once upon a time, and then there was this. So this is the underside of that same panel, and you can see that there is quite a mess of wires, and we wanted to get away from that. So types of panel. So you can base your panels on all sorts of, people have all sorts of ideas about how they're based the panel. So I've sort of listed here a few sort of things that I think they break down. So the real thing has a signal box controlling a small area, and that's certainly how it was when signalling first started. And then more recently, they've got these big operational centres which cover many miles of track, and so effectively electronically. So the signal box, of course, a lot of the control was manual. They did have a few electric if a signal was a long way away, but mostly mechanical. And then the regional ones, which are primarily electronic. So your own how do I go back? Your own design of a panel, you can use mechanics and electronics, or just mechanical. You could use a PC. You could use a mixture of all of them using a central bus, such as C-bus. And we're going to just look at a few examples of that. So here's a small box Loughborough on the Great Central Railway, and this is a sort of typical signal box layout with a section of track that's controlled by, and underneath this board you will see there's a lot of levers that control all these signals mechanically. They've got feedback. These yellow lights are the track circuit feedback from the rails, so that they can see whether there's something sitting in that particular section of track. The signals are just diagrammatic. They don't have any indication. The idea is that the signalman from this vantage point can see what those signals are. Here's a regional. So we're now looking at more modern technology. So this signal box, which is Basingstoke, covers tracks from Waterloo right the way down to Exeter, and in fact other places like Portsmouth Harbour, Weymouth as well. You can see that I don't know, well, it's not a very good photograph, I accept, but it's got effectively the tracks laid out along this panel. These little television screens are for level crossings, so they've got CCTV, so they can see what's happening at the level crossing when they put the barriers down. And actually that's quite frightening, because when I was in the box, which was in the evening, the number of people that tried to get under the barriers before they finally dropped was amazing to me. Just don't understand why people think that it's, you know, in such a rush that they've got to get under the barriers. But again, all electronic, no levers in here, just push buttons on the actual panel itself. Now here's a model where the model has decided he wants to have a prototypical type of arrangement. So he's got mechanical levers that operate the points. Some of these will be using electronics to operate the points, and others are actually rod in a tube, so they're mechanical. And you can see a little bit of his diagram down here, and you can see there's some yellow LEDs here showing which way the route is set for the direct, you know, as he pulls the levers. So this is a large O gauge layout called West Ealing, and this is PC operated, as you can see. This is using JMRI with much adaptation, and this is very much like the real thing in terms of a regional centre. And you can see we've got signals here. Oh, I keep doing that, don't I? We've got signals here. There, we're showing a green aspect, and then the white is the route that is set, and you can see it makes us cross over here, and the signals are set appropriately. The larger one down below is a section of that, and you can see there's a train occupying that loop there, and he doesn't have a signal to come out of there because the road is not set. And that, as I say, this is only one section of a very large O gauge layout, and it's all run off of the JMRI and the computer. This is the JMRI screen. How many of you have seen JMRI or sort of know a bit about it? Quite a few of you? No. Okay. Well, it's probably worth looking at. JMRI is a free download program, and it's worth having a look at that, because it does have some advantages if you want to go down computer control.
How do you spell that?
JMRI stands for Java Model something. JMRI, railway something, infrastructure, I think. JMRI.
Thank you.
Java Model Railway Interface.
That's it. Good. Good man. Glad somebody's on the ball. Somebody's still awake. That's good. Right, and this is a panel that I made, and this is coming towards some of the things I'm going to talk to you about. So this is a panel from my garden railway, which is G gauge, and this is designed to fit into a building. It goes actually inside, the roof lifts up and that goes inside. And on here I've got various things that are really to do with the fact that it's a garden railway. So first of all, I never know whether the points, I might have sent an instruction for a point to move, but actually there may well be a snail at that inappropriate time trying to cross the blades, and actually, although I sent the instruction for the point to move, I don't actually know it's moved. So these signals are really pseudo signals. What they're indicating, if I get a green, if I'm stood in this siding here, if I get a green, that will tell me that this route is set. But it's only telling me that the points have changed. It's not actually telling me what the signal aspect is. So it's by way of just a way of me telling which way the points are set. You've got the yellow LEDs are for route setting, and this works in a way. So if I want to go from platform 1 and I want to go to the relief line here, if I press that LED, but it's a push button, it'll start to flash. So that's the entry point. I then press this one, which is the exit point, and then that will flash. When the route is set, both those yellows will go solid. So I know that I've got a route set from there to there. The red ones are purely because I've got a lot of DC locos and a grandson, and I need to actually, I've got relays on there. Although this is DCC, I've got relays so I can turn this platform off. So I know we won't have any extraneous movements, because my grandson has decided that it would be quite fun to have a head-on collision, which is quite often the case. He thought it was hilarious when my new loco fell in the pond. He thought that was really good fun. I didn't think it was so funny. Right, so my first efforts, I needed to control points and solenoid motors, all the sort of normal things that you have with a DC layout. I wanted some, because it was quite a large layout, I needed LED feedback so that I could have light showing which route was set. I had at that time just 2 DC controllers, and I'd hand painted the track onto a sheet of aluminium. what I didn't realise, because this is in my days of learning about things, I didn't realise that the Hammett and Morgan momentary switches, which I was using in those days, when you flick them from one side to the other, they actually shorted on the case. And because I had the case screwed to the aluminium front, I ended up with every now and then I get a short. And because at the time I'd cadged single core GPO wire to use as my electronics, because in those days I had no money, so it was a question of what I could cadge. It wasn't man enough for the shorts, and I blew up a DC controller. I blew up several solenoid points by that process. So I pretty soon realized that I needed to change from using an aluminium, and I plumped on plywood. The plywood worked well, but there were issues really. First of all, as the layout sort of grew, I had to add additional holes for additional mechanisms to control additional points. And although I had now got hold of some multi-strand wire, I only had one roll, so it had 8 colours in it. So I was now limited to 8 colours. But as you will see, or as you saw at the beginning, you know, the number of wires I had was far more than 8. So of course I ended up with loads of wires going to different places, doing different things that were the same colour. And when I then had a fault, and I'm trying to work out why something wasn't working, it was an absolute nightmare to do. And somebody had said to me, well, you should really tag the end of the line. And I started doing that, but I pretty soon got fed up with the bits of sellotape falling off. So I gave that up as a bad idea. I'd incorporated as well, on top of everything else, I'd incorporated more hand controls. I ended up with 4. And I had a sort of cap control. And I'm just thinking, and of course I added signals and servers as well. I think I go on, I know. Yeah, so here's the panel, which you've seen already actually. These rotary switches here change the line along there to whichever of those colours I've selected. And if you look along here, you'll see I've got inputs. Here's a DC controller that was a handmade one. Inputs in here, and so I can select blue on each of those lines by changing the rotary switch to that particular line, which is the way that I controlled it. But as you saw in the other picture, you know, underneath this is loads and loads and loads of wires, and you can see some of the bodging where I've had to drill extra holes and paint over bits, and as things changed. So then along came sound. Now my mate and I, we used to work the layout together, and he said to me, he said, well, John, we ought to think about this digital thing. And I said, well, I'm not interested in digital. I said, DC's fine. Well, you know, we don't need digital. Well, anyway, then one day he came along and he put a loco on the track. And he bought into Digitracks in a heavyweight, and we had sound. And suddenly I became a convert. I thought, bloody hell, this brings another element to the whole thing. So we tried to incorporate both DC and DCC in the same layout. And in fact, if I go back to that last photograph, here is as it happens at this point, well, there's a Digitracks. You see the Digitrack stuff there. That is actually linked into there. So effectively, the red on here was DCC, and the blue was DC. So at any one of these points, I could change between DC and DCC, which on the face of it sort of worked until you forgot and you ran a loco across between the two, you know, on one of the crossovers, and you got one set on DCC and the other one set on DC. So it really wasn't ideal. And as I've said here, you know, you needed a mortgage to buy all the Digitrack stuff. Anyway, I went to an exhibition, and there was a Merg stand there, and I went along and I chatted to the people, and I was really taken with their display where they were demonstrating how you could control trains with 2 wires, you know, and you didn't need all that section switching malarkey and all that. So so instead of going down the road of scrapping everything I'd done before, I decided to add C-bus into what I already had. So now I had, just to make matters even worse, I had buses for track, I had buses for the low cadet for Digitracks, I had buses for 4 separate DC power supplies, and as well as all the individual feeds to all the points. As I say here, it wasn't the best solution, although it sort of worked. So I've said this already. One of the things that we found is locos fitted with decoders that have the DC facility enabled. I don't know whether any of you know much about that, but if you have a DC, so you can actually get the decoder to work off a DC as well. What happens though, if you get a surge or a short, if you've got that enabled, the loco runs off at full speed. And having had 1 or 2 cascade onto the floor, I decided, in fact, now I do not have the DC option enabled on any of my decoder fitted locos. Also, I found, because I'd run C-bus in amongst all that wire in the cab, if I started soldering the live track, or if I had a short, it sent a spike down the C-bus, or it sent a spike through the wiring, which then caused the C-bus to have a moment, and it would then change all the points, which was fine until you had a loco running across the point at that happened moment. So that became not a good idea. So I then was talking to Pete Brownlow at Missenden in one of the October courses, and he introduced me to his PC design that he'd made for a CAN panel, very similar to the current Merg CAN pan. In fact, I think he uses Mike Bolton's, some of Mike Bolton's firmware in it. The only difference is that the CAN pan does, I think, 32 LEDs, whereas Pete's CAN panel does 64 LEDs. And I needed a lot of LEDs, so I plumped for this, although it wasn't a kit. So I got to sort of know Pete quite well because he was helping me resolve the various issues I had. And in one of the conversations, one of the things I'd had problems with was that when you have one of these CAN pans or CAN panel, you've got to, or even a CAN LED, you've got to set up a matrix. And that resulted in me having to solder loads of wires to different parts behind the fascia. And it was just nearly as bad as the original DC thing we had. So what I did then, I talked to Pete about the possibility of having the matrix actually in the PCB. And we then developed that further by saying, well, if we've got the matrix on the PCB, on a 2-layer PCB, why don't we have why don't we have the CAN panel plugged in directly to the PCB to save that wiring? And then a further thought was, well, why don't we have a fascia on the front that is the same as the PCB that we built, so that all the components match, line up exactly. And indeed, this is what we did. So this is an Eagle PCB. This is the top layer. So on this is a layout, an O-gauge layout actually, Kimball that I'm responsible for. On here you've got signals, ground signals, and the track layout. So immediately underneath that is the PCB layout, and you'll notice here that the red lines are on the top surface and the blue lines are on the second surface or bottom surface, and you can see, generally speaking, the red lines are running horizontally and the blue lines are running generally vertically, and that effectively is the matrix, but basically within the PCB. And this item here is the socket, which you'll see in a minute, and that connects to the CAN panel. And here's the two together. And you can see that actually what we've now got all the LEDs on that first lining up with the track. So when we put the fascia on, the holes line up exactly. So here's the finished article. You've got the track layout as you saw there. We have signal aspects. We have yellow for route aspects. And then we have underneath that is this PCB. And that's the back of the PCB showing the panel connected to it. So of course the big advantage, and this is an exhibition layout this goes on, it's only got 4 pins. So all that lot runs off of 4 pins. So it doesn't matter where we plug that in. We can plug it anywhere on the layout where there's C-bus. And it doesn't have to be in one place. So for an exhibition layout, it's very fortunate. And in fact, we do have a couple in a club who have difficulty going underneath the board. It's a roundy, the club layout. And so we can actually bring the panels out to the outside so that they can work it either side of the layout, which is quite handy. Here's another shot of a different panel, just showing again the way the components are actually sold directly to the PCB, so there's no wires. And again, you can see the horizontal part of the matrix and the vertical part of the matrix. And here's the back, and here's the cam panel, and it simply just plugs in to the back of the panel, like that. Here's another shot, and you can see here are the 2 layers. Here's the PCB with the tracks on it. This is the fascia, which we've laser cut, and there's the cam panel just plugged in, and all the components are just directly soldered. So what are the snags for doing that? Well, there are some. First of all, if you then change your mind and want another siding or want to change the format, clearly it doesn't work very well. I have managed some simple modifications using extra bits of wire, but it's not a good plan really. So you are stuck with what you got. So it's the sort of thing you might do once you are absolutely definitely settled with what you're going to do. The other thing is that when you order the PCBs from China, which aren't very expensive, but you do have to get 4 because their minimum order quantity is 4. So it does mean you have a spare, but you know, it's unlikely you're going to need 4 panels all identical. Yeah, because the other thing with using electronics is if you have a problem with the CAN panel or C-bus, you can't operate anything. Everything just comes to a grinding halt. So, any questions?
What size is that final PCB, John?
Yeah, you got me. The final, well, I've gone up the, I've actually, I'm in the process of building another one. I don't know whether you can see that. That one's 400 by 170.
I'm still seeing your slide, John.
Okay, just stop sharing for a minute then. Right, can you see it now?
Yeah.
Yeah, I got that.
Yeah, so that's 400 by 170. But the others are smaller. So you can choose your size. It's just whatever size you feel you want.
Another question, John. The CAN panel, that could be used in a conventional way, I take it, the same as CAN pan,
Yes.
via the plug and socket job and wired to wherever.
Yes, exactly. So the advantage of that over the CAN pan is just that it has more 64 LEDs and 64 switches, whereas the CAN panel's only got 32. And in fact, Pete and I are developing another one that will do 128 LEDs, but that's still work in progress at the moment.
That'll be an equivalent then of the CAN Ace 3C, will it?
Be much bigger than that, yeah. Yeah, the CAN Ace 83 does it? That doesn't do.
No, the 3C.
Oh, how many does that do?
That's 128.
Oh, right, I didn't realise that. Okay, yeah, equivalent, as you quite rightly say. But the CAN Ace 83 only does push buttons, doesn't it? Switches.
I'm not sure. I'm not using one, so I'm not down to that bit.
I think it does LEDs, whereas the CAN panel does both.
So that's right. Okay.
Any other questions? There's somebody trying to talk, but I can't hear them. Brendan's trying to talk. We can't hear you.
I think they need to unmute. Got mute on. That's why I can't hear him.
Unmute.
No, we still can't hear you. No, Brendan, you're. I can't read your lips.
Brendan, just press your space bar when you're talking.
I don't know if he's got the right microphone selected.
No.
According to me, he's not muted.
No, he's not muted. I think he's not got the right mic selected. Anyway, I think he's given up. Any other questions?
What about incorporating feedback from the track?
Yes, that is actually on there. In fact, what I can, let me just, I share again. Now, if I
John, while you're doing that, Brendan's just sent us questions a chat. He's asking how much the PCBs are.
the big one that I've just done, that was £40, but four of them, so £10 each. The small ones were about 20 quid for four, so they're really inexpensive at the moment from China. That may well change, of course. I don't know why I can't get this. Why is this not working? No, I don't want to cancel that. Okay. Sorry about this. I was going to show you. Ah, that's better. Right. So on this panel here, what we're using on this layout, we have, as I say, it's a round O gauge layout. It's 40 foot long by 20 foot wide, 16 foot wide, and we have effectively 4 operators, 2 on the front of the layout that drive the locos, and they drive the locos to the signals. And then we have 2 operators in the back on a storage yard that marshal the trains and get them ready to depart. And then we have a 5th operator who is effectively the signal manager or signalman or in charge, who operates all the points. Now, in order that the drivers know what aspects of the signals, because some of these signals they can't see, we produce this panel, which is called a driver's panel, which sits in front of the driver. And on here, he's got the aspects of these red and green aspects will show up the color of the signal. And they are using feedback. So they're not actually being told electronically. They're actually waiting for a switch movement. So when the semaphore board moves, it puts a micro switch on and gives feedback to the driver that the signal's gone from red to green, so you can proceed. The yellow LEDs here, which are the route set. So if we took this crossover here, there's 3 LEDs here. If the route was normal, that LED there would light, and that LED there, oh, that LED, I can't click it, can I? That LED there will light. When the push button by the signalman is pressed, those 2 will go out and that one will light. And so the driver can see what route is set. And that is from feedback from the points. We use tortoise motors, and each tortoise motor has an additional microswitch on it. And that feeds back to a CAN compute. And so what happens is we can't clear a signal if the route is set against it. So for instance, if we'd had a route coming out of here, set across a crossover and proceeding up that direction, this signal here, the signal will not be able to clear that signal because it's a conflicting route. So we've got a degree of interlocking. It's not absolute, but there's a degree of interlocking. So does that answer the question about getting, somebody asked, I can't remember who it was, asked about feedback?
Yeah, it answers my query, yes.
Yeah,
Thank
okay.
you.
Okay. Anything else anybody wants to know? I did put up on the end on that. Oh dear, oh dear, oh dear. You can tell I've done this before, can't you? Oh, I've lost one on my. Oh, you know, when I saved that just now, I must have deleted one of the things. I had a little thing of all the things we've used. So the CAN panel, you can source that if you look at the www.rmeuk.com site. You'll find all sorts of PCBs, kits, and all sorts on that. These are basically Peter Brownlow's stuff. The little, I'll stop sharing. The little LED push buttons, they came from Mouser. They're very expensive. Well, £2.60 each they are, so they're quite a pricey item. The only other component that was not rapid, all the rest were rapid, but the only other component was from RS, which is the socket that went on the back of the PCB. So it's all sort of quite readily available. And the Eagle program, I mean, some people are using, I can't think of the name now. Not
Design Spark.
Design Spark, absolutely. Some people are using Design Spark. We just happened to hit on Eagle. It was a free downloadable. Once you sort of got your head around how those work, it's a bit difficult then to change to another one, but there's plenty out there. And of course, at the moment, the whole thing revolves around the fact that you can get the PCBs cut in China very cheaply. I mean, the quickest turnaround we had was 4 days. We put an order in, and it came back through the letterbox 4 days later. And how they do that, I do not know. You know, but I think that's all will all change. You know, we'll just make use of it while we can.
John, what was that address? www.rmu.
RME.
Sorry?
RME.
RMT,
Railway Model Experts. RME.
Oh, RME, right. Thank you, John.
UK. .com.
Thank you.
And I could probably show you if you want.
Can you? Yeah. Just a check.
You just
John, you might be able to find that slide that you deleted in your bin and reinstate it.
Yes, probably could, couldn't I? So, can you see that?
See that?
See that?
Yeah, thank you.
There's various things along here.
Experts.
So we do, there's various kits. These are all kits that aren't in the Merg kit locker. So we only have them here if they're not part of the normal Merg kit locker stuff. So there's various things. And we've got connector boards as well with various things. I use this quite a lot. All these designs are designs that we've done for ourselves, and then our people have asked, so we put them on a website. But that one I use quite a lot. That's for C-bus, so I can actually link in an additional C-bus line, so I don't interrupt the C-bus loop. I don't know, it's
150.
yeah, you can see there. You can use it for two poles as well. I tend to use pluggables a lot, only because I've not had good experience with screw terminals, especially when you're trying to unplug and plug in, do something, plug it back in. It always seems to be a nightmare. So I use pluggables. There's a downside of using pluggables because obviously every connection you make is a potential area for it to be,
Connector.
have a slight fault or a loss. But yeah, so there we go.
John, do you have to join this group to buy these kits like Merck?
No, they're not like Merck. You don't have to join Merck. This is just for anybody. So you just log on. You can actually buy them from the site. This is a board I've done recently for old Hammond and Morgan points. I don't know whether any of you are familiar with that. The old style points. I wanted micro switches on it, so I made up a board so that I could have micro switches on it. So you just add it to the cart. I presume you can see all this, and put on how much you want. Go to the checkout, and it takes all the normal sort of cards, and then we post it out to you. Any other questions?
Not a question, John, but I just went looking for that website while I was listening. I don't know if it's changed. It's actually rmauk.com.
Did I not say that? I thought I said that. I beg your pardon.
I think you just said RME.
UK, yeah.
.com.
UK. Yeah.
.com.
Yeah.
.com, yeah.
Mm-hmm. Okay.
And we're doing the laser cutting as well with the this is sort of recent. One of our team has got a laser cutter now, so we're doing this engraving. I've got there's another one I've done recently, and it's effectively a 2-color plastic. The top layer is one color, and then the base layer is white. And so what you do with a laser cutter, you engrave the green layer away, and then you can dig the holes out, and you can cut all the way through to the holes. But it does produce a really smart looking fascia. But as I said earlier, the trouble is, if you make a mistake, then it's you can't do much about it really. It's already done. Well, you can redo it, I suppose. Okay. So, is there any more other questions for anybody?
John, could you come and design my layout for me?
Yes, for a price.
A big price.
Yeah, but this O gauge layout, I've never been a club member because I've had this friend that we always used to meet together, but I've had to move away from, I'm an hour away from him, so we don't meet as much as we used to. And I've joined the Leamington and Warwickshire Club, which is a lovely club. They've got beautiful premises, really. They've got O gauge, a large O gauge layout. They've got 2 or 3 N gauge layouts, a P4 layout, and a couple of O gauge layouts, all actually out in the room, so you can tell what sort of size room it is. They've got the kitchen and all that, and so that was a really new phenomenon for me. But I was quite interested in the O gauge and sort of sidled up to the group that were running that, and they were bemoaning the fact they've been using ZTC, and they'd already blown up a couple of O gauge decoders, which aren't cheap. You know,
No.
a couple £100, because, and they didn't know why. So I said, oh, well, I'll have a look. The first thing I noticed was that they had obviously got a big reel of speaker cable, which was fine, except it was all the same colour. So they had this white cable running all the way around the layout. And of course, there was trying to identify which end of which cable belonged to which was impossible. And we found out eventually that the ZTC system wasn't man enough. When there was a short, it didn't shut down, not properly. And what was happening was you getting a spike going through the track, and that was frying the decoders in the locos. So I said to them, well, why don't we use Merg? And they agreed. And then of course, unfortunately, I became the expert. So it was my responsibility. And I thought, oh, that'll be easy. Just change the wiring over. Just put a couple of CAN commands and, you know, well, 1 CAN command, a couple of 3 boosters. Piece of cake, no problem at all. Well, 2 years later, and I'm still working on it. You know, it's not an undertaking that you should take on lightly. So yeah, designing a layout and running it, particularly if it's a large layout, can take a fair amount of time.
Anybody got any other questions?
Yeah, Jim McPherson's come up with JMRI. Oh yeah, that's right, JMRI.org. That was what we were looking for earlier. Yeah. Good.
Org.
The only other thing to say to you is if there's anything in here subsequently you think, oh yeah, I'd like to know how to do that, I'm quite happy to answer emails and stuff. So just send me a mail and I can, you know, I'm happy to see what I can do to help.
There is a thing about that JMRI, John. It also includes Panel Pro and Decoder Pro. So if anyone's in DCC, they can use Decoder Pro to read their encoders. They don't have to use JMRI.
Yeah, I'm not sure I understood that. Yeah, Decoder Pro is a part of JMRI. Is that what you meant?
Yes, that's right. It's part of the download, but you can it's standalone. You can use it separately.
Oh yeah, yeah. Okay.
Well, if there's no more questions, do we want a general chat, or should we finish the meeting? If you click the participants button, I see that we have a yes and a no. So